All right, well, I think we can go ahead and get kicked off for the day. I want to say hello. My name is Hillary Porras, Head of Marketing and Communications here at RDL. I want to thank everyone for joining us today for our RU-NMP44 product overview session. Chuck Smith is going to get us started here in just a few minutes. But before we dive in, I want to make you all aware that we do have a Q&A function at the bottom of your screen. So if any time during this presentation you have any questions, please feel free to use that chat function. And our head of technical support, Ralph Wilkin, is on the call today. He'd be happy to answer any questions that you have at any point during this presentation. So please feel free to type your questions in and we'll get those answered. And with that, I'll hand it over to Chuck to get started.
Wonderful. Good morning, everybody. I also want to thank everyone for coming to learn a little bit more about our new RU-NMP44 network mixing processor. This is a great product. Before we start, I want to give you a quick background of who RDL is and our values. If you're not aware, RDL initially started making audio solution products for the radio broadcast industry nearly 4 decades ago. The broadcast industry demands that their audio products produce studio quality audio signals, they have precise adjustments, and they are extremely reliable. RDL designed and engineered our initial products to meet those demands, and we've maintained the same production quality, and high standards through today. We build all of our products in-house at our factory here in Arizona. And this hands-on approach allows us to oversee every step of the production process and know that we're delivering products with unmatched quality and reliability. We also have a very experienced technical support team who's ready to assist you with your projects and product needs. Since the beginning, our customers have relied on RDL to support everything from standard commercial projects to mission-critical installations around the world. RDL's reputation is built on trust. We will always do the right thing because it's the right thing to do. That is our company culture. This presentation will be divided into 5 parts. First, I'll play the short introductory video in case some of you haven't seen it. Second, I'll review our software configurable interfaces and our compatible remote controls. Third, I'll review several system application drawings to show you the flexibility and the versatility of the RU-NMP44 and to help you better understand how to use it. Fourth, I'll give you a brief overview of our Console 2.0 software. And then last, I'll show you the basic programming features for the RU-NMP44. I hope by the end of this presentation, you'll have a strong grasp of where and how to use this processor and feel that it's very easy to program and configure. So with that.
Every day, there's a venue in your region looking to add multi-zone audio. It could be a brewery with different areas, a fitness center, a hotel, or so many more unique applications. What if this venue needs to route different audio signals to different zones, especially in real time? What solution should they apply? Analog? The control would be complex, it would be hard to install, and the labor costs would be high. Network digital? Better, but how can smaller venues afford a complex, expensive DSP system? Introducing the RU-NMP44 network mixing processor from RDL. The RU-NMP44 is a cost-effective network audio solution that offers like network audio distribution, multiple mixers, priority ducking, multi-channel level control, and has both network and analog outputs. Custom configurations can be stored as presets for instantly recalling switching, mixing, and level changes. And with a variety of remote control options, the RU-NMP44 is the perfect mixing processor for any audio system, any size, any budget. With nearly 4 decades of innovation and industry experience, RDL is proud to bring you our latest creation. This mixing processor was designed from the ground up to be versatile, while providing all the principal features and functionalities you need to support a wide range of system designs. It starts by sending 4 Dante network inputs to 6 4x1 mixers. 4 of them output to Dante channels, and 2 output line level. Each mixer offers automatic priority ducking with selectable high-pass filters, perfect for venues like schools and healthcare facilities, where clear announcements are vital. Audio can be distributed up to 6 zones, 4 through Dante and 2 analog. You can use single or multiple remote controls to change presets and adjust individual features for each zone. Imagine a hotel, resort, or restaurant seamlessly controlling audio levels across separate zones with ease. Lobby, reception, foyers, and beyond. Whether it's the core product in a single audio system or part of a larger design, the RU-NMP44 is ideal for adding volume control, mixing, switching, or ducking to any network system. From the beginning, RDL has earned a reputation for building high-performance audio products that are trusted in installations throughout the world. And like all our products, the RU-NMP44 is proudly made at our facility in Prescott, Arizona. Simplify your network audio system with the RU-NMP44 network mixing processor from RDL. High-performance audio products made in America.
Great. Okay, so next I'm going to talk to you about our software controllable units and the remote controls that would typically be associated with the RU-NMP44 in a system design. First, I want to talk to you about the software that's needed to configure our audio products. Most of you are familiar with Dante Controller, which is primarily used to route the signals in a network audio system. RDL's Console 2.0 is a free downloadable software program that operates in conjunction with it by providing the product configuration features that you need for setting and adjusting RDL software controllable products. These include the RU-NMP44, our configurable endpoint interfaces, and our network remote controls. Some of the configurable products are wall-mounted interfaces such as these, the DD-RN31, RN40, and RN42. The DD in the model number stands for dual decora. The RN stands for remote network, meaning this wall plate is software configurable. These are all professional grade interfaces with features like studio quality mic preamplifiers, analog filtering to enhance the sound, plus they're constructed with all steel chassis and front plates. All the setup features like input gain, mic line selection, phantom power, and output levels are fully software configured and controlled. Now, this is the DD-BTN44, a Dante Bluetooth interface that was originally all physically configured, meaning it was adjusted with physical buttons and switches. Recently, the Bluetooth pairing features and the module ID name settings were upgraded to be software configurable. Although there's a convenient pairing button on the front panel, you can even perform the pairing function itself through software if you like. These 3 remote controls are compatible with the RU-NMP44. Starting from the left, the D-NMC1 network remote control with screen is a multifunction remote control that connects directly to a network switch. It can be programmed to adjust all the inputs and outputs for all 6 virtual mixers in the RU-NMP44, as well as the priority ducking features and more. It can make entire system adjustments by activating custom presets or provide live control over individual features. Basically, it can be programmed to control many functions or just one like volume, whatever's needed. The one in the middle is the DNLC1 network remote control with LEDs, which provides level control or volume control. The volume ramp up and ramp down speeds can individually be adjusted. Both of these network remote controls can be set as either a primary remote or a satellite control, where up to 8 remotes can work together in sync to control one system. Last, the DRC4M 4-channel remote control is an economically priced analog remote that connects directly to the RU-NMP44. This unit is used to activate the 4 system presets on the RU-NMP44, and up to 3 of these remotes can be wired together. Technically, you can use all 3 models simultaneously in a single system, which I'm going to show you in a couple of system examples. So the system application drawings that I'm going to show you were designed to showcase the many ways the RU-NMP44 can be used. These applications are all featured in our RU-NMP44 applications brochure, which can be downloaded from the unit's product page on our website. The first one I want to talk about is mix 4 sources independently to 6 zones with priority ducking. So if you look at the system diagram, I'm going to start from the bottom left and go clockwise. Here you see 4 microphones that are being input to one of our interfaces. In this case, it's the SF-XMN4, which is a mic to network interface. All 4 mics connect. They're converted to 4 Dante channels. It's routed through the network switch in the system to the RU-NMP44. And of course, the laptop sits in the middle where it's actually controlling the individual settings for all 6 mixers. Like it was mentioned in the video, all 4 microphone signals, all 4 Dante channels, are distributed evenly to all 6 virtual mixers. So each one can be configured independently. Now, in this case, mic number 4 is being deemed as the priority mic. Each mixer can individually select how it wants to use the ducking feature, or if it wants to ignore it altogether. The next system example is called 4 presets, activate system configurations, and this one's featuring the DRC4M in the bottom left corner. So with our 4-channel remote control, you can actually go into the RU-NMP44, completely design a system configuration and save that as a preset, and then have up to 4 presets total. Again, the DRC4M is what actually, the push buttons on the front panel are what actually activate those presets. So in this case, we're showing 2 zones, but it could easily be a system design with 6 zones. I think a good system example to get your arms around how this works might be a restaurant. Even if that's something you don't normally do, it would apply to any type of commercial audio project. But in a restaurant, this might be an easy way to understand what we're trying to accomplish here. So for example, let's say zone 1 was the front lobby. We want a little bit of background music present, but we also want to be able to do some paging to let the people waiting for a table know that their table is finally ready. In zone 2, that might be the rest of the restaurant, including a bar section, a sports bar area, something like that, where I might want to have some level of paging, but I'm more focused on the background music. So as an example, I could set preset number 1 to be my breakfast setting. Maybe the background music's a little low level, the ducking feature, the page doesn't have to be that loud. Everybody's kind of calm and quiet first thing in the morning. Preset number 2 could be for my lunch setting, where I have a few more attendees. Things are getting a little bit louder. I want the paging levels to be raised up a little bit. Preset number 3 could be my dinner function, where I want things to be much louder. Now I have a lot of people who are waiting for their table in the bar section. Maybe they're watching their favorite sports game while they're waiting. And I want that paging to be a little louder in the bar section. So I would adjust all my levels according. And then the 4th setting could be the nightclub setting, which is after dinner is served, maybe 9 o'clock on, where we've really gone into a nightclub mode. I no longer need to worry about paging, and we've got all the volume levels raised considerably. So again, just to give you an idea of how this can be configured. Now, if you look in the middle of the drawing, we've also added 2 DNMC1 remote controls in each zone. And these are just, in this example, these are just being configured for volume control. So even though I initiate a particular preset, I can always go into those actual zones on the wall and raise the volume level up or down a little bit as needed. So I have live control as well. The 3rd example is a single remote level control for 6 zones. I'll give you a corporate meeting room environment. I think that might be a good example of how this could be used. We want to set the levels with one of our presets for all of the 6 zones. But at some point, we've noticed that maybe in zone 2, the presenter is speaking a little soft, and we want to elevate the sound system a little bit more than what was set up on the preset. So in the middle of the drawing, you'll see there's a DNMC1 network remote control. Now, these controls are completely individually configured. So again, my screen could actually have zone 1 through 6 listed. It could actually be the 6 independent names of the rooms themselves, whatever makes sense to the end user. And I would scroll up or down to the 2nd zone, click enter, and all of a sudden the screen would change to a volume control. Now I just simply increase or decrease the volume as needed, hit enter, and the screen is restored back to the first page. Very simple and easy to use for the end user. The next example is called local level control for 6 zones, and this is kind of the opposite of what we just described. In this case, we're using 6 DNLC1s. These are the network remote controls with LEDs that are designed just for level control, and we've put one physically in each zone. This might be better for meeting rooms, let's say in a resort, where the meetings are more typically self-contained by the group. And we just want to give them local access to the volume control for the overall sound system. Anybody can run up to a wall and increase or decrease the volume level as needed. I actually see this being a very key example of how the RU-NMP44 could be used in many system applications, standalone or as part of a much bigger system that has additional DSP units as well. And the last example I'm going to give you is network room combining system for 3 rooms. And I think this one is ideal. This is where we're going to use the RU-NMP44 to actually be the controlling processor for a 3-room combining system. If you're not familiar, especially like in smaller hotels, like an airport hotel, it's very common to see that they have one decent sized meeting room that can actually be divided into 2 or 3 sub rooms. And the way they do this is by removable walls. They're sometimes called air walls. So for this example, we're using a 3-room system where the room can be divided into 3 separate sections. We'll call it room 1, 2, and 3. The input, in order to keep each one of these rooms completely independent, the input plate for that room section has to actually feed an amplifier that powers the speakers directly for that section and that section only. That way, when the air walls are pulled in, every room is completely independent from the others. And to connect to the system, we're actually using our DXLR3F, which is an XLR wall plate. And these are wired to our interface, which is the RU-NMP44P. This is a 4-input bidirectional interface, and each input can actually be individually set for mic or line level. In this case, the 3 wall plates for the 3 rooms, we're actually going to set those to line level. And the reason for that is it's very common in a hotel meeting room environment for the property manager or IT manager to actually walk in with a small 4-channel mixer for each of the groups. And this 4-channel mixer will accommodate the podium mic, audio out for the laptop, a smart device, and it mixes everything down to line level output, which is typically an XLR output. So it's perfect for connecting to the DXLR 3F plates. So these 3 plates are then sent out to the network, and they go to the RU-NMP44. Each one is connected to an individual mixer. So for room number 1, the wall plate is connected to mixer number 1, room 2 is mixer number 2, and room 3 is mixer number 3. All 3 of those mixers are dedicated to the network amplifier for each of those room sections. So here's how we designed it as a combining system. For preset number 1, I would simply keep all 3 rooms independent. So mixer number 1, I would only have the very first fader elevated on the mixer. Inputs 2, 3, and 4 would be completely off. And that means whenever anybody connects to DXLR3F in room 1, the signal is routed through the processor directly to the amplifier, and it only plays into the speakers for that room section. The same would apply to mixer for room number 2 and mixer for room number 3. In the second preset, I removed the air wall from the first 2 rooms. So now rooms 1 and 2 are one larger room, and room number 3 is still an independent smaller room. So here on this preset, I would actually take the first 2 mixers and elevate the faders for the first 2 input channels. Now, it doesn't matter which of those 2 plates you connect to, the signal is actually going into both mixers and playing into both amplifiers and speakers simultaneously for rooms 1 and 2. So now room 1 and 2 seamlessly acts as one larger room, and room number 3 is still independent. Preset 3 would be the opposite. I'd combine rooms 2 and 3 as the larger room, and room number 1 would be the smaller independent room. And then preset number 4 was where we would remove all the air walls. It would be one big meeting room. I would raise the fader levels, the first 3 fader input faders on all 3 mixers, so that no matter what wall plate you connect it to, the signal will go to all 3 amplifiers. The entire system acts as one big combined meeting room. Now, keep in mind, there's a 4th input available on this system, so that would be ideal to add a priority paging source. And also, just to give you a different design example, instead of wall plates, you could actually substitute those with our DBT1A Bluetooth interface in case you wanted to have all the attendees connect wirelessly. So again, you're starting to see that this is a very flexible network mixing processor. Now, I want to talk a little bit about our software and give you a general overview of Console 2.0. First, how to find it. Go to our homepage on our website, and in the top header, you'll see products. Click on it to open up this sub window and just scroll down to console software, click on it, and it'll take you to the console software page. There's another way to get there, and that's by clicking on the product page of any of our software configurable products like the RN series. Click on that or the RU-NMP44 page, and you'll notice that towards the bottom, there's an RDL console software link. Click on any of those and it'll take you directly to the console software page. Now, once there, you'll notice that on the middle left, you'll see a download button. And in that button will always be the latest version. It's a great way to just check to make sure you have the latest version of this software. Again, it's free, downloadable. Once you actually download it and activate it, the software pings the entire network to see every single Dante product, RDLs, and other manufacturers' products that are in the system. And it divides it on this page, as you see here, it divides it into 3 separate sections. The first one on the top is called RDL controls, and this means our network remote controls. The second one is controllable units. This means our software configurable devices like the RU-NMP44 itself and the wall plates I showed you a few slides back. The third section actually will be comprised of all of our non-software configurable products, the ones that are physically adjusted with buttons and switches, and other manufacturers' products. Once it detects all the products in a system, if anything is disconnected, the little window pane that represents each product will turn red. Maybe you've disconnected it to configure some physical features if it's that type of product, or a network cable or a switch port has gone bad. This is a great way to identify which one is no longer connected to the system. As soon as it's restored, the background will turn gray. Throughout this program, we have help files that can be accessed in many different ways, and it's all accessed by these question marks, these green question marks you see circled here. If you click on a question mark that's more toward the left, it's going to bring up more general features. So the first thing, you're going to see a dashboard that's outfitted with multiple different options. The system options, controls, meaning network controls, controllable button, which means software configured products, other Dante units, which are the physical and other manufacturers, and so on. If you were to click on a question mark that's a little bit further in to the right of the dashboard, this is going to be more specific, and it's going to take you to that section of the help file where it specifically deals with the product you're clicking on. So in other words, if I click on the first one for RDL controls, it brings me right to the help menu that talks directly about our network remote controls. And here's the 2 different, the DNMC one and the DNLC one to choose from. If I click on the help file question mark for the controllable units, it brings up all of our software controllable products, the RU-NMP44, all the RN wall plate versions, and so forth. And then the last one is going to be for the other Dante units, which again are physically configured RDL products or other manufacturers' products. There's 2 other buttons here. The first one with the rotating arrows, this is the refresh button. And when you click on it, it queries the network for all Dante products. It'll actually discover everything out there, unless there's some products that are under Dante Domain Manager. Sometimes those products aren't detected. So the way to get around that is the bottom button, which looks like a magnifying glass with a plus in it. This is a scan feature, and it'll scan all the IP addresses on an active network. This will definitely discover all the RDL configurable products in a system. Something else I want to point out too, this software is completely riddled with what we call tooltips. And what that means is when you hover your mouse cursor over any one of these features, a small little descriptor will pop up and tell you what the button is. It's to kind of remind you what that feature is for. Now, let's talk about the access panes. So again, there's an access pane for every single product. If you had a particular wall plate, for example, maybe you had 40 of them in a system, the DDR and 31, you would actually see 40 DDR and 31 access panes. So in the pane, the first thing that you see right up front is the name and MAC address, the IP address, the model of the product, and the manufacturer. If you notice in the bottom right corner, there's a little settings gear icon. Just click on this and that opens up the interface that's directly dedicated to that product. So each time you click on a different product gear setting, you're going to get a completely different graphic view. So in this example, I'm clicking on the RU-NMP44, and you're going to see mixer faders and things of that nature. If it was more of like a wall plate, you'd see things that allow you to adjust whether the input is mic level, line level, the different gain settings, phantom power, so forth and so on. Now, for the other Dante units, the hardware configured, in other words, non-software configurable products or other manufacturers' products, there's still some useful information. This provides information for our, this includes additional status and Dante routing information, which is very helpful for the installer and the IT managers. Now, let's talk about some basic programming. This is the last section of my presentation. And here I'm going to talk about the basic programming of the RU-NMP44, just show you how actually easy it is to configure this unit. So as before, select the gear icon on the bottom right corner, and that's going to bring up the product dashboard. The first thing it defaults to is the status page, which again shows the model, address, and routing information. The very next option on the left is the mixers panel. Click on that, you're going to see all 6 mixers listed on the left. Click on one, the button highlights green. And now you've got the 4 inputs and the 1 output for each of the virtual mixers. The input names default to RX1 through RX4, as in receiving channels 1 through 4. And the output channel name defaults to TX1, as in transmitting channel 1. Like all Dante product signals, these names can be changed in Dante Controller, and those custom names will appear here in the mixer panel. For example, you'll see I changed the first input name to receiver 1 channel and the output to line out 1. Of course, you can name these whatever you like. All faders provide level adjustments and 1 dB increments for precise level control. The values range from 0 dB, which is up full, to negative 64 dB, which is fully off. The next panel section in the system is the output attenuation panel. This panel groups all the outputs from the 6 mixers in one convenient page. The first 4 faders on the left represent the mixers that output Dante network signals, and the 2 on the right represent the mixers that output analog line level signals. Like the individual mixer panels, these 6 faders adjust the output levels in 1 dB increments for precise adjustments. And for convenience, there are 6 group level adjustment buttons on the left that allow you to increase or decrease the overall system level in 1, 3, or 6 dB steps. For example, once each individual zone is adjusted to your liking, you may decide the overall system needs to be louder or softer, and these group buttons provide a great way to make that adjustment. The next option is the ducking configuration panel. And this is where you select one of the 4 Dante input signals to be the priority paging signal. The first field at the top shows the name and MAC address of the specific unit to be controlled. And this is especially useful if there are multiple processors on one network. Next is the priority channel selection field. Click on it to open a drop-down menu. Here you can choose one of the 4 network inputs to be the paging source. If disabled is selected, no ducking will be applied. The next field is the high-pass filter selector. This function rolls off low frequencies from the paging source. For an example, an open microphone might be picking up the low frequencies of an HVAC or AC unit, or maybe there's hum noise in the system. And these frequencies can sometimes create a false trigger and engage the paging function when it's not wanted. Rolling off some of the low frequencies can stabilize the detection function, or you can select none if no filter is needed. Next is the recovery delay. Once the page ends, whether it's a live page from a human or a pre-recorded message, a countdown timer is engaged to restore the system levels back to normal. And this timer can be set from a half second to 10 seconds. You typically want to set the delay long enough so that it extends beyond the silent pauses between sentences or the silent period between a recorded message that might be looped several times. Once the wait time is reached, a second process called the recovery ramp restores the system levels back to normal. The duration of this restoration period can be adjusted from 1 to 10 seconds. So for example, you may want to restore a teacher's audio system in a classroom after hearing a page from the principal's office. You may want to restore that very quickly. An example of a slower ramp time could be where a diner type restaurant might have an old style jukebox. After a customer's song selection ends, it may sound less abrupt if the regular background music source ramps up slowly. especially if it's in the middle of a song. Next is the threshold field. This simply means the paging source level that must be exceeded to trigger the ducking function. Any signals with levels lower than this threshold will be ignored. The bottom section allows you to customize how each of the 6 mixers will be affected by the ducking function. First, select only the mixers that you want to be affected. Here I chose mixers 1 and 3. Mixers 2, 4, 5, and 6 will ignore the ducking function. However, that paging source signal is still distributed to each mixer to be used or not used, however it's needed. Selecting a mixer opens up a drop-down menu. Let's say, for example, I selected input 3 near the top of the panel as the paging source. In the lower section, input 3 is now highlighted blue, indicating it's the page source. Inputs 1, 2, and 4 will be ducked when a signal louder than the threshold setting is detected on channel 3. The priority channel levels will turn green during the ducking cycle. The ducking levels for the other channels can be individually adjusted for each mixer. These change values are represented as dBr, which, unlike dB that represents a signal level, dBr stands for dB relative, meaning a value that changes the existing level up or down. For example, if input channel 1 on mixer number 1 was set at -10 dB, a -20 dBr level would lower that signal level by 20 dB when the ducking cycle engages. In other words, the initial -10 dB signal level will be lowered to -30 during the page. Again, each input on each mixer can be adjusted individually. Not only that, but there's an override output level feature that's available. At the bottom of this panel, you'll see an override selector button for each mixer. Select this and a drop-down menu appears, giving you the option to change the paging signal to a desired level. Although you set an initial input level for the paging source, you may need the priority channel to be louder or softer in various zones. This operation allows that feature. So you can simply select the desired paging level for any zone. In this example, mixer number 1 for zone 1 has the priority channel level set to -20 dB, where mixer number 3 for zone 3 has it set to 0 dB, where it needs to be much louder. The original paging level is just fine for zone number 5, so the override output feature for mixer number 5 is unselected. Next is the preset panel, and this lets you program and store up to 4 complete system configurations for instant recall. First, know that any of the presets you create can be selected as the power on default. Most network systems used to stay on 24/7, but now it's becoming more common to shut these systems down each night for security reasons, such as to help prevent system hacking. The panel field at the top is where a preset option is selected, if that's how you want the system to reboot. Or you can select last state, which means it boots up to the last setting adjustments made the day before. And then a third option is you could select all off, where all input and output levels boot up to the fully off positions. Now select any preset to configure it. When you click on a button, it expands and shows the current levels and the various pull-down choices. Only the mixers you select will be affected by this preset. In this example, mixers 3 and 4 will not be affected when preset 1 is activated. Clicking on each mixer's input or output field presents a drop-down menu, and here you can set the desired input and output levels. When it's complete, click on the save icon at the top to store this configuration, then repeat the process for the remaining 3 presets. Now you can activate a preset in several ways. One option is by clicking on the button to the left of the preset in this panel. It'll turn green, telling you that it's actually been engaged. Of course, you can activate them using the DNMC1 network remote control, and you can also activate it with our DRC4M analog remote control. You can also use an external switch or an open collector to activate presets by wiring them to the analog remote control terminal block connector on the back of the RU-NMP44. So again, you can see this is a very versatile product. And last, the dashboard feature provides additional Dante information for each input. And that wraps up my presentation. Be sure to learn more about the RU-NMP44 and all of our products on our website at rdlnet.com. We welcome you to follow us on LinkedIn and Instagram. And you can find this and all of our contact information on our website. I want to thank you again for your time and interest in learning more about the RU-NMP44. It's very appreciated. And now I'll turn everything back over to Hillary.
Great. Thank you, Jeff. Yeah, I want to thank you guys again for attending our webinar today on the RU-NMP44. We do have a little bit of time left, so if anyone has any last-minute questions, our team will stay on here for a bit to answer any final questions that come through the Q&A feature. And of course, if you think of anything after our session, please feel free to reach out to us at any time. So if you don't have any further questions, that concludes our webinar today, and we want to thank you again for joining us. We hope you enjoyed the session, and we look forward to hosting more of these in the future. Thank you again, and we hope you enjoy the rest of your day.
Thank you.